Welcome to solverfy.
I'm going to work a problem that uses Kirchhoff's voltage law, which says that around any closed loop, sum of the voltage drops is equal to 0. This problem has a little bit of a different twist on that in the top loop, but still we're going to use KVL, and we have to figure out a couple of missing voltages first. So we can work on the, let's say, on the bottom right-hand corner, that smaller loop in the circuit. And if we look at that, we have going around clockwise rather, we have 6 volts, and then we have this unknown voltage, I'll just call it voltage 2, and we have a negative 4 volts. We add those up, they have to equal to 0, and that means that V2 is equal to 10 volts. And that is to say that going that direction, it's plus minus and 10 volts. So we can use that in the top loop. If we look at each side of the circuit, where we have Vx and Vy, and then we have that 12-volt voltage differential, that potential there in the middle. And so on the left-hand side of that upper loop, we have Vy, we have a plus minus Vy, and a plus minus 6 volts, and we have a plus minus 12 volts. And so Vy plus 6 volts must equal to 12 volts, and therefore V sub y is equal to 6 volts. And if we look at it on the other side, then we have, again, that 12-volt potential, and then over here we have plus minus V sub x, and we also have a minus plus 10 volts. And so 12 volts is equal to V sub x minus 10 volts. And so therefore V sub x has to equal to 22 volts. So it's a little bit different with that strange voltage potential there in the middle, but you could almost think of it like hooking up a multimeter there in the middle of the circuit, and you would have Vy and 6 volts on one side, and they would have to equal that voltage potential. But still just a basic application of Kirchhoff's voltage law, especially to find this intermediate voltage.